So, like Abby said previously, we started out with just the basic Tetrick designs for our robot, and we immediately recognized the need for some type of driving mechanism for the robot. Yeah. So, using the first parts we discovered were definitely gears. So we employed that into making a drive chain, and the first drive chain we used was 1-to-3 gear ratio, which made the robot slower but more powerful. And as you can see in this picture, all the gears and wheels were linked together, so they were all turning simultaneously and would not would all be turning at the same speed. And we recognized after testing that a few times that it was going to be a little too slow for our needs and driving around the field. So we changed that to a 4-to-1 gear ratio, which made it the wheel spin approximately 4 times as fast as the motor speed, which gave us a little bit too much speed at that point, and that was employed onto one of our later robot designs.
How did you know you had too much speed? How did you know that you had too much speed?
It was a little almost reckless on the field, and we couldn't control it from destroying.
Was it funny?
Well, I think that was the stage where we still had a bunch of wires trailing behind it, so it was hectic.
And then if you're going to talk about too much speed, you might also want to mention just the grinding problem that we were having, or gears slipping out as well.
So also with our excessive speed on our robot design here, we also came into our first trouble with gear grinding and gear slipping, which kind of foreshadowed our. Okay, so anyways, so after that we were starting to begin attaching some of our utilities and such onto our design. So we decided for our final few robots to have no gears on the drive chain, but just have motors, and that provided the right sort of stability.
Too long. The two of you are going to end up taking all the time. Selena is over here. She's trying really hard to stay focused, but it's hard to do because it's so long. Think about the most important thing that you want to share. Catch me if I'm wrong, but I don't think the judges are interested in every minute detail. I think they're interested in your aha moments.
You might want to just summarize how we went through a lot of robots and we were testing things like the many gear
Prototype.
systems and having a lot of motors to power this robot. And that's how we eventually came to this more simple chassis that you have on the actual robot.
Why isn't she? Okay. Go ahead.
That's fine. I was going to say a few things. You were looking at pictures, but I couldn't tell which pictures you were looking at. Abby was always pointing, so I would suggest you point so the judges have something specific to look at. I would say we went through a drivetrain that, I'm just going to throw it out, was like the 3 bears with Goldilocks. One was too fast with gears this way, one was too slow, and then we found the one that was just right, was direct driven or something like that. Literally in 2 or 3 sentences, and you can say, here's one that was too fast, and we geared it up, and we ran around the field and smashed into things. And here's one that was too slow. The other thing, I like the way you guys said, basically what happened is you talked about the drivetrain, and you talked about what are called the actuators, the other things that manipulate stuff. But I didn't kind of know that's how you were breaking it up until he got almost all the way through this. So I would even say, I'm Abby, I'm going to tell you about how we manipulate the box.
Oh.
This is what we went through to do that. I'm Evan, I'm going to tell you about the drivetrain, and these are the things we went through. So I would almost introduce it as, and you could even say, now Evan's going to talk about the drivetrain when you do that handoff to him. So, does that sound
You are
good?
very articulate.
Well, I know about everything. I've been reading through the engineering journals.
And I would even say YouTube could probably go off sometime and just practice your speeches and time yourselves. And if you go for about 5 minutes, 5 or 6 minutes, and if you're going too long, you guys can give each other feedback without all of us.
Probably less than, we have 10 minutes to do
Well, the whole thing's 20 minutes, but usually the last 5 to 10 are for the judges to ask you questions. And you still have to do your T-shirts and your school and your outreach and all the other, your programming, your autonomous programming and your teleop programming.
But that should take a little pressure off because you're not having to stretch out. You're not having to go into so much detail about the robot.
We can definitely.
All right, so you're finished, and who would be
You
next?
end with?
Well, I was going to go a little farther. Yeah, so, and that's when we incorporated our gears that we target That's why we incorporate your ears into our final robot.
Wait, hold on, what, never mind.
Good, what?
No, you're gonna say something I completely, it's just,
I was just looking for the, and now person X is going to tell you about thing Y. What were you gonna say?
Selena's gonna talk about our programming.
okay, so what am I supposed to say for the programming?
Did you end up back at programming again?
Yeah.
How did you end up back at programming
Well, I
again?
mean, I was thinking about talking about the tank drive, how it's sort of like unique, I guess. Sort of.
Okay.
I don't know if it's unique,
Right.
but anyway.
Give it a shot.
Is that it though, or should I talk about the teleop or static?
Yeah, teleop and autonomous.
I guess.
How did you know what are your controllers? What are your buttons? How did you decide which buttons? How did you decide? Is it one controller for the whole robot, or are the two drivers doing different things?
And talking about the tank drive, you might want to just discuss how some people were actually requesting that you do that specifically because they had been driving with the other controls and it was more complicated.
Okay. Alright, sounds good.
Wait, so,
Before I forget, very briefly. Also, Abby, just in the middle of yours, at one point you said the other team did blah blah blah.
Yeah,
Yeah,
You
I,
hadn't introduced. We had another team in Albemarle High School when we were working with them.
Right.
Blah, blah, blah. So just make
but
sure.
someone else.
that would have gotten
you're-
really
Yeah,
not because it was a person from Vertigo helping us, but they were talking about the Defying Gravity robot.
that's totally fine. I mean, there's nothing wrong with saying we did all this design and then we saw a YouTube video and this looked like a great idea, so we threw that away. We did this, or we did all this design and we saw like doing this.
Well,
and
we
said,
did
"Oh, that's a
kind
great
of do
idea."
that.
That's totally fine. There's nothing wrong with that.
I'm following his lead on this because I don't have any experience. So it's it's all good.
But we had our own editions, which were the RAM, 3D printed RAM.
Okay, so let's give you the opportunity to talk.
Okay.
So you would say, and here's Selena.
Here's Selena, who's going to tell you about our programming.
Okay. Well, I don't know, I'm so confused what to say. We'll just talk.
Okay. So what are you going to mainly be telling us about?
I'm not sure, actually.
But you know,
Okay.
one, you can program in Robot C. It's worth saying because a lot of teams don't do Robot C.
Oh,
Some teams use LabVIEW, which is the easier, not as complex version. And then, you know, the two main things are autonomous and teleop. So what does your robot do in autonomous and how did you program it? And what does your robot do in teleop and how did you program it?
and then you said something about the drivetrain,
The tank drive.
tank drive. So
Alright.
it's
so-
okay. It's all good.
So our program was written in Robot C, and so for the teleop we had it on two remotes. And so one person would be controlling the motions or the movements of the robot, while the other person controlled the manipulators, or the drivers, I guess. And then so at first we had it so the person who controlled where the robot went would just, forward was forward, backward, the joystick was back. But then they requested that we change the program to a tank drive, where one joystick was controlling the left wheel and the other one controlled the right wheel. For the manipulators, basically each button controls either the lifting mechanism or the flat raiser. And so you press one button and it go up, and then the other button will make it.
Oh, are you going down? Practicing like that right now. Okay then.
Does it dump too, or does it?
Yes, yeah, it just goes up and then the blocks slide up with that.
Oh, right. So it's literally lifted
Yeah.
and it just slides off. Okay. That's kind of a cool feature. It's
You
pretty
did it.
simple. It's simple control that way.
You did it, and that's all you have to say.
I would say again, now autonomous you didn't talk about. Is it
Oh,
right. Autonomous? That's fine for teleop.
Okay. Well, for our autonomous program, we made it so the robot would start in the corner and drive straight towards
They're
the
driving
pendulum. It would then figure out
Driving?
using an IR
I
sensor where the beacon was, so it could earn more points. It would drive towards the basket with the beacon, drop the block in, and then drive around and up the bridge, and then just wait there until the period.
Okay, I don't want to talk. You're
Yeah, pretty much.
I was trying to tell her to talk. She wasn't doing it.
Okay. And then
Does it go around either side of the
Well,
pendulum?
it depends on which side it goes to.
Okay, so it
Just
does
the
go
closest
to
side.
the
Yeah.
closest side.
so who would talk after you?
I think that's,
you and Gus and Emma.
so
And now Gus and Emma will talk about.
And now Gus and Evan will talk about
Team progression.
The team progression.
So as Avius had said, we started off as a rookie team, so we were all new to robotics and Tetrix as well, while a few of us had done basic programming. So throughout the year, we had became more adept at constructing and building robots as well as programming, and we came together as a team substantially, and as we
Are you guys ready to come in and run your robot around a little bit?
No,
We need a
the
couple
middle of the
minutes.
judging
It's in the
session.
middle of your session.
We
We don't have much
need
time.
to, I know, we'll be in there.
And so, as you can see in our robot progression, as we constructed our robots, we also came together as a team to more efficiently create these. And then Gus, I think, is going to talk about how we came together in the other part of this.
Alright.
And